Hello class, I am Mr. Sutton and today we're going to be talking about skill 22, compound inequalities. Here is your definition for compound inequalities. Make sure you get this down. A compound inequality is an inequality that combines two simple inequalities. Here's an example where x is less than 3 or x is greater than 5. Here's how we would represent that in a number line. So your solution is anything less than 3 or anything greater than 5, not including 3 or 5 because these are not less than or equal to or greater than or equal to symbols. That's why we have the open circles there. So here is an example of one we would have to solve. So solve for x and graph the solution on the number line below. So in order to solve ones like this where we have two separate inequalities, we would just solve the inequalities separately and then try to combine our answer onto a number line after the fact. So I'm going to go ahead and start with this inequality here. Negative x minus 7 is greater than negative 15. This is how I would solve that. First, I would add 7 to both sides, and I'd have negative x is greater than negative 8, and then I would divide both sides by negative 1, where I would get x is less than 8. Remember, if you divide both sides by a negative number, you have to flip your inequality sign. That's why I went from greater than to less than. So x is less than 8 is going to be part of my solution. Next, I'm going to solve this other inequality I have here. And this is how I would solve that. First, I would add 7 to both sides again, which would leave me with negative x is less than or equal to negative 11. Then I would divide both sides by negative 1. And you get x is greater than or equal to, flipping the inequality again, positive 11. So our answer would be x is less than 8 or x is greater than or equal to 11. And if I put that on a number line, I'm just going to use a simplified number line, just have my 2 points here being 8 and 11. So that would be everything less than 8 would look like this. Again, open circle because we're not including 8. And then over here we would have a closed circle because we are including 11 and saying everything greater than or equal to 11. So this is what our solution would look like. Any number inside of these bolded parts is a solution. Here is another type of compound inequality you have to solve, and this is when our two inequalities are combined like this. So in order to solve this, it's the same thing you would do to solve a normal equation or inequality. You want to get x by itself. So in this case, to get x by itself, first we would have to get rid of this plus 7. So I would subtract 7. The only difference is now I have to subtract 7 from all sides of this inequality. So I have to subtract 7 here as well, and also here. So there's 3 different places where I need to subtract 7. I think that is where a lot of us make mistakes on these. 31 minus 7 is 24. Is greater than 2x. 7 minus 7 is 0. Greater than 27 minus 7 is 20. Now to get x by itself, I need to divide by 2. So if I divide by 2 on that side, I need to divide by 2 on these other two sides as well. 24 divided by 2 is 12. Greater than 2 divided by 2 is just 1, so I have 1x. Greater than 20 divided by 2 is 10. So this would be my solution here. And we want to write these usually from least to greatest. So I would say 10 is less than x is less than 12. I'll flip it around. And the reason why I want to do this is because that is how our number line is set up. So that's going to help us make sure our number line is in order. So here our solutions are everything between 10 and 12. So 10 is less than x is less than 12. So it's everything between those two values, not including 10 and 12, because we don't have equal to signs here. So open circle here, open circle here, and we just want to fill in everything between. That would be our solution for this one. So a couple things to note about compound inequalities. We've seen two different types here, conjunction and disjunction. So conjunction is the second one we looked at. That is this one. So those are and types, because you might also see them listed as two different inequalities with and in the middle. And for those, both inequalities must be true. So like if we look at this previous one, x is greater than 10 is true, and x is less than 12 is true. So we don't want anything outside of that. So like if I said 14, 14 is greater than 10, so it makes this one true. But it does not make the other side of it true. It does not make the less than 12 part true. So 14 would not work, would not be a solution, because this would be an and inequality. The other type is disjunction. These are or types, so that's like the first one we looked at. And for this one or both inequalities must be true. So in this case, only one can be true. So for example, x is less than 1 or x is greater than 5. Or we can look back at this one. So this is also a disjunction type. So if I said 5, for example, 5 meets the requirement of this part. 5 is less than 8. That's part of our solution. 5 is not greater than or equal to 11, but that's okay because this is an or type. So we don't need to satisfy both inequalities in order for this to be a solution. So that's an or type. And this is an and type where the numbers have to satisfy both inequalities to be true. So those are the two types. Make sure you have this down in your notes. And we're going to look at some more examples going with these two types here. So here's an or type. Solve for x and graph the solution on the number line below. If possible, resolve your answer to a single inequality. In case of no solution, you would use the empty set symbol here, meaning no solution, and then leave the number line blank. So let's go ahead and take a look at this. We're going to solve both of these inequalities individually. So I'm going to start with this 16 is less than x plus 9. I'm going to solve that. So I subtracted 9 on both sides, and I got x is greater than 7 for that one. So now I need to solve this other inequality. 18 is less than or equal to x plus 9. So I'm going to go ahead and solve that. So here when I subtracted 9 on both sides, I got x is greater than or equal to 9. So those are my two inequalities here. 7, or x is greater than 7, or x is greater than or equal to 9. So when I put this on the number line, I would say open circle here at 7, because we're saying greater than 7 but not equal to. And then I would shade in everything above that. And then for this, x is greater than or equal to 9, notice that that part is already shaded in, right? We already have included 9 and everything above that in this x is greater than 7 part. So since this is an or statement, we don't have to shade that in again, and we can use just this x is greater than 7 because that includes both of these. So we can go ahead and say this is our final answer, and this is what that would look like, and we can forget about this because that's already covered in this x is greater than 7 part. All right. So now let's go ahead and take a look at this one. Notice this is an and statement. The same question here, solve for x, graph the solution on number line below. If possible, resolve your answer to a single inequality. In case of no solution, empty set, leave the answer line blank. So I'm going to go ahead and solve this first one. It's 15 less than negative 2x plus 1. So for this one, I got x is less than negative 7. So now I want to go ahead and solve the other inequality. Negative 1 is less than negative 2x plus 1. So there I got x is less than 1. So here I'm trying to say that x is less than -7 and x is less than 1. So if I want to put this on a number line, I have 1, I have -7 would be below that. So I want to have an open circle here at -7, and I want to shade everything less than that. And then if we want to think about the other part where x is less than 1, so if I think about these solutions here that are between -7 and 1, if I wanted to fill in, like just thinking x is less than 1, so I would supposed to fill in, shade in this area right here, but think about how this is an and statement. So if it's an and statement, then we only want to fill in the parts where both inequalities are true. So everything above -7 already does not fit with this inequality. So if I'm thinking about x is less than 1, none of these parts would be a solution because they don't fit this inequality. So the only parts of this inequality that work are also the ones that are less than -7. So once again, we would discount these solutions and we could just simplify and say x is less than -7 is our only solutions. So I want to take an extra slide to highlight the difference between or statements and statements when we are simplifying. So when we have our inequalities going the same direction, these are both less than, that's when we can simplify. And there's a difference between, let's do the and statement first. So when we are saying x is less than -1 and x is less than 1, for those, we would just uh, use the solutions that include both. So in this case, it would just be less than -1. Because say, for example, 0 is less than 1, but it is not less than -1. So that is why we would not fill in this area in between, even though these numbers are between, or even though these numbers are less than 1, you might think they're solutions, but they're not less than -1. So they do not satisfy both inequalities. So we would only do this part. We would only do x is less than -1, and we can simplify and forget about that part. But if it were an or statement, we would go ahead and say x is less than 1 is our solution, because remember, for or statements, it can satisfy one or both inequalities. So, for example, 0 works because it is less than 1, even though it's not less than -1. Since it's an or statement, it only needs to satisfy one inequality to be the solution. So for or statements, we can simplify and get rid of, that's not what I'm about to do. We can simplify and get rid of the less inclusive statement and just simplify and use the more inclusive statement. So when we're using and statements, we have to simplify and use the less inclusive one. When we're using or statements, we can simplify and use the more inclusive one. So that is the difference. Think about what those words mean when you're trying to simplify these things. Make sure you take a note of this picture. Hopefully that helps illustrate the difference between and or. I have one more example here because I could not find one like this on Delta Math, so I wrote it in, but I think it's possible that you could get one like this on Delta Math based on the way the question is asked. So I'm going to go ahead and solve this inequality on the left. And I got x is less than -5. Now I'm going to go ahead and solve this inequality on the right. And I got x is greater than 2.5. So if you combine these, if you say x is less than -5 and x is greater than 2.5, and try to figure out where the overlap is there on the number line, there is none, right? If you think about values less than -5, that would be going this way, and values greater than 2.5, that would be going this way. And since this is an and statement, we only want to include parts where they overlap, where both of these inequalities are true, and that would be neither of those. If I say like -6, for example, that satisfies this inequality, but does not satisfy that inequality. It is not greater than 2.5. If I say 10, for example, that satisfies this inequality. It's greater than 2.5, but does not satisfy this one. It is not less than -5. So this would be one where we would say no solution. So you can only get no solution on compound inequalities that have and in them, and it is and ones where you have no overlap whatsoever. So that is how you would solve that if you see something like that on Delta Math. I went through a lot of problems and could not find one that was like that, but it is possible that they could give you one like that, especially since it tells you what to do in the question if you encounter a no solution one. So I assume that there's a possibility. So if you see one, reference this problem, and you want to write the empty set, which is the circle with the slash through it, for your answer, and that would be a no solution. If you have any questions about any of this material, make sure you are going to office hours, asking your teacher for help during class. Have a good day.